I am looking at the astrometric data coming in from the ExoMars Trace Gas Orbiter and the latest telemetry from the Deep Space Network, and I have to be honest, what we are seeing with 3I Atlas is defying the standard models of cometary mechanics in ways that make me uncomfortable. We have been tracking this object, designated C2025N1, but better known now as the third interstellar visitor, 3I Atlas, since the Atlas survey flagged it back in July. When Oumuamua came through in 2017, we were caught off guard. When Borisov arrived in 2019, we were ready and confirmed it was just a rogue comet. But this is different. We are currently sitting in late November 2025, just weeks after its perihelion, and the behavior of this object as it aligns with the ecliptic plane and accelerates away from the Sun is not just unusual, it is statistically improbable to a degree that demands a complete rethink of our formation models or, and I say this with extreme caution, our understanding of interstellar traffic. The primary anomaly, the one that keeps me up at night staring at the orbital integration software, is the alignment. Interstellar objects shouldn't be here in this specific orientation. The galaxy is vast, a three-dimensional halo of stars and debris. When an object is ejected from another star system, it travels through the galactic void for millions or billions of years. When it approaches our solar system, it should come from a random inclination. It should plunge down from the galactic north, or shoot up from the south, or come in at some sharp, oblique angle relative to the flat disk where Earth, Mars, and Jupiter orbit. That is what statistically must happen. Oumuamua tumbled in at a high inclination. Borisov dropped in at a steep angle. They treated our solar system like a sphere they were piercing through. 3I Atlas is different. It is behaving as if it knows the traffic laws of our local neighborhood. The orbital inclination is approximately 175 degrees. Now, in orbital mechanics, 180 degrees would be perfectly retrograde, moving exactly opposite to the planets, but in the exact same flat plane. 175 degrees means it is effectively skimming the ecliptic. The geometric plane defined by Earth's orbit around the Sunday. It is moving effectively backward relative to us, but it is doing so while staying almost perfectly flat within our planetary disk. The odds of a random rock ejected from a random star system just happening to thread the needle and enter our system within 5 degrees of our planetary plane are vanishingly small. We are talking about fractions of a percentage point. It aligns with the other comets and planets in terms of its vertical space, sharing our highway, but driving in the wrong lane at 60 kilometers per second. This alignment forces us to ask immediate questions about its origin. If it's natural, it implies that perhaps there is a dense population of interstellar objects specifically confined to the galactic disk, a thin disk population that we are only just now detecting. It suggests that the space between stars isn't a chaotic swarm of debris, but perhaps has structure, a dynamical coherence that funnels objects along specific galactic gravity wells that coincide with our own system's orientation. That's the conservative astronomical view. It's exciting because it changes the physics of galactic dynamics. But then you look at the strange move it made near perihelion, and the conservative view starts to fracture. We watched it dive toward the Sun in late October. Perihelion was on the 29th. We expected it to behave like a standard ball of dirty ice. We expected sublimation. As a comet approaches a star, the heat penetrates the crust, turning frozen volatiles water, carbon dioxide, carbon monoxide directly into gas. This outgassing creates the coma and the tail, and acts like a weak rocket thruster, pushing the comet slightly off its purely gravitational course. We call this non-gravitational acceleration. Oumuamua had it. Borisov had it. 3I Atlas has it, but the magnitude and the direction are wrong. The data we received from the solar orbiter and the perturbations measured by the ExoMars team suggest that the acceleration 3I Atlas experienced near the Sun was distinct. It didn't just speed up. It seemed to correct its course. I am looking at the velocity vectors now. As it rounded the Sun, experiencing the intense tidal forces of our star, the non-gravitational push it received has placed it on a precise intercept trajectory with Jupiter. Now, nature is full of coincidences. I see coincidences every day in the data. But this is a sequence of coincidences. First, the arrival in the ecliptic plane. Second, the survival of a perihelion passage that should have fragmented a body this small. Third, a non-gravitational boost that fine-tunes its exit path to pass within the Hill sphere of Jupiter in March 2026. Let's talk about that move toward the Sunday. In the weeks leading up to perihelion, the light curve of the object, the graph showing how its brightness changes over time, showed erratic periodicity. Some of my colleagues are arguing this is evidence of a tumbling state, a chaotic rotation caused by outgassing jets, firing randomly. That is a valid hypothesis. If you have a jet of carbon dioxide erupting from the side of the comet, it will spin the nucleus up. But the periodicity we saw in the high-resolution Doppler imaging hinted at something more stable, almost gyroscopic, and when it hit that point of closest approach, 1.36 AU from the Sun, the thermal stress was immense. We should have seen a massive coma expansion. We should have seen megatons of water vapor. We didn't. The spectra we are analyzing right now, taken by the James Webb Space Telescope's NIRSPEC instrument just days ago, show a shocking lack of water. The water abundance is less than 4% by mass. Instead, we are seeing strong lines of cyanide and nickel, an abundance of nickel that is orders of magnitude higher than any solar system comet we have ever studied. It's metal-rich, it's dry, and it's moving with a precision that mimics a gravity-assist maneuver. When a spacecraft like Voyager or Cassini uses a planet to gain speed, it dives into the gravity well and steals a bit of momentum. 3I Atlas essentially performed a gravity assist using the Sun, but the assist was augmented by this mysterious non-gravitational force. This brings me to the alignment with other comets aspect of the current situation. There is a family of comets known as the Kreutz Sungrazers. These are fragments of a giant comet that broke apart centuries ago. They all follow a specific path, a line of pearls diving into the Sunday. They are local, they are ours. 3I Atlas is not a Kreutz Sungrazer. Its hyperbolic excess velocity proves it is not bound to our Sunday. It is traveling too fast to stay here. Yet, for a brief window during its approach, it mimicked the inclination of these local families. It hid itself, dynamically speaking, among the local traffic. This mimicry is what makes the strange move so baffling. It masked its interstellar nature until we calculated the eccentricity and realized, wait, this thing isn't stopping. Its eccentricity is over 6.1. For reference, a perfect circle is 0. A standard ellipse is between 0 and 1. Anything over 1 is hyperbolic, leaving forever. At 6.1 is extreme. It is bullet fast. I want to address the shape discussion that has been circulating since the new radar images came back from the Goldstone Deep Space Communications Complex. The signal-to-noise ratio is low because of the distance, but the cross-section is elongated, highly elongated. We are seeing an aspect ratio of perhaps 5:1 or 6:1. This mirrors Oumuamua, which was cigar-shaped or pancake-shaped. Why do interstellar objects tend to be this shape? The leading natural theory is that they are shards, fragments of planetary crusts, ripped apart by tidal forces in their home systems before being ejected. If 3I Atlas is a shard of an exoplanet, a piece of a shattered world, it explains the shape, but it doesn't explain the nickel. A crustal fragment should be silicate-heavy, rocky. This spectral signature suggests a core, a dense metallic core stripped of its mantle. But let's look forward, because the past perihelion is done. The object is now moving outward, and this is where the situation gets critical. We are predicting a close encounter with Jupiter in spring 2026. This is not just a flyby. The trajectory, refined by the data from the Mars orbiters, which got a side view of the comet as it passed, shows it threading the needle of Jupiter's Lagrange points. It is going to pass through the region where the gravitational pull of the Sun and Jupiter balance out. These are gravitationally stable corridors. If I were designing a mission to deploy sensors into the solar system, I would target these exact coordinates. I am not saying it is a probe. As a scientist, I cannot say that until I have a techno-signature. A radio beacon, a laser flash, a distinct, unnatural maneuver that violates the conservation of momentum. We haven't seen that yet. What we have seen is strange, but strange is not artificial. However, the alignment with the ecliptic and the targeting of Jupiter forces us to consider the dark comet hypothesis. A dark comet is an object that has cometary acceleration from outgassing, but no visible coma. The gas it ejects is transparent, or the dust is too large to scatter light effectively. If 3I Atlas is a dark comet, it explains why we didn't see a huge tail. It explains the push. But why the nickel? Why the lack of water? The latest paper dropped in the preprint servers this morning, and it discusses the galactic rest frame. This is the coordinate system of the galaxy at large. When we correct for the motion of the Sun, 3I Atlas appears to have been sitting relatively still in the local galactic neighborhood before our Sun ran into it. This is the same profile Oumuamua had. It suggests these objects are like buoys floating in the galactic ocean, and our solar system is a ship plowing through them. But if they are just buoys, why did this one have a trajectory so perfectly aligned with our ship's deck? The probability of a buoy being aligned with the ecliptic plane by chance is, as I mentioned, minute. This has led some of my colleagues to propose that there is a stream of materials moving with the local standard of rest that preferentially populates the ecliptic due to some dynamical friction we don't understand. Yet, I'm looking at the thermal infrared data now. The surface temperature of the object during perihelion spiked to over 600 Kelvin. It baked. If it were a loose pile of rubble, the tidal forces of the Sun combined with that heat should have elongated it further or broken it apart. We saw C 2024, S1, Atlas, disintegrate under similar stress. But 3I Atlas held together. It is a monolith. The structural integrity required to survive that gravity turn at that speed implies a high tensile strength. This brings us back to the metal hypothesis. An iron-nickel body could survive that. A loose ice ball would not. We are also seeing magnetic anomalies. The magnetometer on the Parker Solar Probe, which was in a fortunate position to catch the solar wind disturbance as 3I passed, registered a hole in the solar wind plasma. The object seems to be shielding itself, or interacting with the solar magnetic field in a way that suggests it is highly conductive. A metallic object moving through a magnetic field generates a current. This induction heating could be the source of the energy driving the outgassing that we can't quite see. It might not be sublimating ice. It might be electromagnetic braking or acceleration. This is speculative, but the data from the Parker probe is robust. The disturbance in the heliosphere was significant. Let's discuss the spinning controversy. You've seen the clips online, the processed footage from amateur astronomers, and the leaked raw frames. People are saying it looks like it's rotating artificially, or that there are detached shells of dust. From my analysis of the raw FITS files, what people are calling shells are likely rotational artifacts in the image processing of the coma. When you have a rapidly rotating object emitting jets, it creates a spiral pattern, like a lawn sprinkler. Because we are looking at it from a specific angle, those spirals can look like concentric rings or shells. It is a beautiful phenomenon, but it is standard fluid dynamics. It does not mean it is a shield or a structure. However, the rotation rate is accelerating. This is the Yorpi effect, Yarkovsky-O'Keefe-Radzievsky-Paddock effect, where sunlight spins up an asteroid. But for 3I, the spin-up is happening too fast. The torque being applied to the body is massive. I want to pivot to the implications of the aligning aspect mentioned in the title of this situation. We often think of the solar system as isolated, but if 3I Atlas represents a member of a vast population of ecliptic-aligned interstellar objects, it means the solar system is permeable. It means we are constantly being polluted by material from other stars, and this material is being funneled right into the zone where Earth lives. The panspermia implications are staggering. If these nickel-rich, organic bearing, we detected complex organics, tholins, on the surface, impactors are common and aligned with our plane, they are far more likely to strike planets than we previously thought. We might be looking at the delivery mechanism for life, or the mechanism for mass extinctions, operating on a galactic schedule. The strange move toward the Sun also challenges our planetary defense protocols. We spotted 3I Atlas in July. Perihelion was October. That is a warning time of 3 months. If this object had been on a collision course with Earth, we would have had 90 days. And because it came from the direction of the Sun, or close to it, during part of its approach, and moved so fast, it was incredibly hard to lock down the orbit until it was right on top of us. The fact that it aligned with the other comets camouflaging itself in the background noise of the Kreutz family makes it a perfect stealth impactor scenario. We need better eyes. We need the NEO Surveyor and more observatories like the Vera Rubin telescope to be looking not just for near-Earth objects, but for these interstellar interlopers that travel at speeds we can't intercept. Now, about the Jupiter encounter. This is the next big phase. As 3I Atlas climbs out of the gravity well, it is losing speed relative to the Sun, but it is still moving at hyperbolic velocities. It will cross the orbit of Mars and head for the Jovian system. On the 16th of March 2026, it will be closest to Jupiter. The interaction there will be complex. Jupiter is a gravitational bully. It usually kicks comets out of the system or eats them. But because 3I has such high energy, Jupiter can't capture it. It can only deflect it. But here is the nuance. The non-gravitational acceleration we observed near the Sun seems to have positioned 3I to pass on the leading side of Jupiter. Dynamically, passing on the leading side versus the trailing side determines whether you gain energy or lose energy. The current projection shows it losing a tiny fraction of energy to Jupiter. It is giving momentum to Jupiter. Why? A random object has a 50/50 chance, but coupled with the solar interaction, it feels deliberate? No, I shouldn't use that word. It feels dynamically constrained. It is almost as if the object is surfing the resonances of the solar system. We know that mean motion resonances, like the 3:2 resonance of Neptune and Pluto, protect objects. Is it possible that 3I Atlas is following a stability manifold, a path of least resistance through the gravitational turbulence of the solar system? If so, it implies a level of orbital selection bias we haven't accounted for. I have been running simulations of the origin point. If we trace the orbit back, correcting for the galactic potential, it points roughly toward the Carina-Sagittarius arm, specifically the association of young stars near the Vela region. This is a volatile, star-forming region. It makes sense that a young system there might be ejecting protoplanets. But the timeline doesn't match perfectly. The travel time would be millions of years. The surface erosion from cosmic rays during that transit should have altered the spectral properties more than we see. The surface looks fresh. The lack of a thick crust of weathered organic goo, like on Arrokoth, suggests it hasn't been in deep space for billions of years. It looks like it was ejected recently. But from where? There are no nearby stars in that specific vector that match the velocity profile. This leads to the dark horse theory, that 3I Atlas isn't from another star system at all, but from our own Oort cloud, kicked inward by a passing star or a galactic tide. But if it were from our Oort cloud, it shouldn't have hyperbolic excess velocity. It should be bound. Unless it was scattered by a Planet 9. This is a stretch, but if a massive unseen planet exists in the outer solar system, it could sling an object inward at such high speeds that it looks interstellar. The alignment with the ecliptic supports this. A Planet 9 would likely be roughly in the plane or slightly inclined. If it kicked 3I Atlas at us, the object would maintain some of that planar alignment. The high nickel content would then imply that Planet 9 is scattering the cores of destroyed differentiated objects. It turns 3I Atlas from an alien visitor into a messenger from the edge of our own home. However, the speed is just too high. To get that velocity from a Planet 9 kick, the planet would have to be incredibly massive, or the interaction incredibly close. The Occam's razor answer is still interstellar. But the ecliptic alignment remains the stumbling block for the random interstellar theory. I cannot overstate how weird it is. Imagine walking into a busy city square where everyone is walking in random directions, and suddenly seeing someone sprinting at full speed in an exact straight line that perfectly matches the grid of the pavement, ignoring the crowd. That is 3I Atlas. The data from the ALMA Observatory in Chile has just been processed regarding the dust tail. It's faint, but it's there. And the grain size is large. Usually, comets release micron-sized dust smoke, essentially. The ALMA data suggests millimeter-sized grains. Sand. Gravel. This thing isn't venting smoke. It's shedding grit. This supports the mantle-stripped core theory. We are seeing the regolith of a destroyed world being blown off by the solar wind. The strange move or acceleration could be caused by the uneven shedding of this heavy grit, which carries more momentum than gas. It's a pebble rocket. We are now waiting for the Hubble Space Telescope to get some time on it, now that the sun angle is favorable. We need to measure the rotation curve more accurately. If the rotation is speeding up, we need to know the tensile strength limit. At what point does it fly apart? If it spins up to a period of less than 2 hours and doesn't break, it is solid metal. That would confirm the nickel spectral data. If it breaks, it's a rubble pile. The next few weeks of observation are critical. I also want to touch on the signal rumors. There was a report unconfirmed and likely noise of a radio transient from the direction of 3I during perihelion. The Breakthrough Listen team has been pointing the Green Bank telescope at it. So far, silence. Just the thermal hiss of a hot rock. The signal was likely solar interference. We are at a solar maximum, remember? The sun is screaming in radio frequencies right now. It is very easy to mistake a solar burst reflecting off the comet's coma for a signal from the comet. We must be rigorous. We cannot jump to conclusions just because we want to believe. But even without aliens, 3I Atlas is a messenger. It tells us that the galaxy is not empty. It tells us that the ecliptic plane is a special place, perhaps even a collection point for interstellar drift. It tells us that we need to be watching the sun, because sometimes things come from the glare, moving fast, aligning with our planets, and executing maneuvers that test the limits of our physics. The strange move wasn't just the acceleration, it was the audacity of the trajectory. To skim the sun, align with Earth's plane, and target Jupiter, it is a celestial bank shot of the highest order. As we watch it fade into the dark, heading for its rendezvous with the King of Planets, I am left with a sense of profound humility. We are sitting on a small rock, and the universe is throwing stones at us. Most miss. This one grazed us. And in its grazing, it showed us how little we actually know about the kinetics of the Milky Way. I will continue to update the logs as the Jupiter encounter approaches. The gravitational interaction there will be the final test. If it reacts to Jupiter purely by Newton's laws, we close the book and call it a weird rock. If it does something unexpected there, if it adjusts, well, then we have a very different conversation to play out. For now, we watch, we measure, we wait.